For the next installment of section 1.2, we talk about scientific notation. First, let's go into the how and the why. Scientific notation is useful primarily when looking at numbers that have a lot of digits. For instance, the mass of an electron, as you can imagine, is very small and is expressed as follows. This notation is known as decimal notation, where all the digits are fanned out and shown. But it seems like the numbers starting at 9, way down the line, are the important ones, but the decimal spot has to move 31 places over to even reach these values. The scientific notation of this number would be expressed as 9.10954 times 10 to the negative 31. So even though this value is very small and has a lot of zeros, it again seems that the numbers beginning at 9 are the important ones, and that 10 to the power of minus 31 seems to be counting the number of decimal places we had to move in order to reach these values. So that's all what scientific notation is recording. The values here is known as the significand, and the 10 to some power is called the order of magnitude. The significand contains the significant figures, or the level of precision. I could have expressed this number as 9.11 times 10 to the negative 31, and even though it's still accurate, it's just less precise. So depending on the application, the more significant figures I want to record. The significand always has one integer to the left of the decimal, where the rest are to the right. The rules for the order of magnitude are pretty simple. If ever I see positive exponents, that equates to a very large number, whereas negative exponents in the 10 equate to a very small number. For a large valued example, let's consider the topic of radiation. The reason that an element such as uranium-235 is radioactive is because it has billions of trillions of neutrons that are flying off of the atom at speeds very, very high, which means they penetrate everything, everyone, and of course can be lethal if you are exposed to it for too long or exposed to too much of it. The speed at which this neutron is flying is approximately 62 million meters per second. Again, this is why it's dangerous when you have billions of trillions of these flying in your direction. Even though this number isn't terribly large, I can at least identify significant figures of 6 and 2, and I can move the decimal place 7 spaces over to express it as 6.2 times 10 to the 7th power, and this number can change depending on the source that you're looking at. The number from the slide before showed a very small number, which had 10 to a negative exponent. This number, which is large, has 10 to a positive exponent. Now let's talk about how to convert from one form to another. We're going to convert two decimal numbers into scientific notation. First, let's take a look at our number, figure out the significant figures, and move our decimal place over just enough to where exactly one number would be to the left of the exponent. We can do this by moving the decimal place 6 positions, and this would give me the number 1.21301 times 10 to the minus 6th. Again, I have a small number, so I should give it a negative exponent. Notice that we didn't include that rightmost zero into our significant figures because I don't have a non-integer behind it. So all I care about is that last non-zero integer, which in our case was a 1. The next number we'll look at is 21,301,000,000,000. My significant figures are 21301, and I need to move the decimal place 13 places over to get a value of 2.1301 times 10 to the 13th. I have a large number here, so that gives me a positive exponent. Now we'll go from scientific notation to decimal numbers. It's essentially the same process, but in reverse. Here I have 3.59 times 10 to the minus 4th. Negative exponent means small value, so I'm going to move my decimal place 4 places over to the left. This is going to give me 0.000359. Next, take the number 4.201 times 10 to the 5th. Positive exponent, large number, so I'm going to be moving my decimal place 5 places over to the right. This will give me 4,201,000. The last exercise of this video shows us how to multiply and divide numbers written in scientific notation. So consider the following quantity. Even though this looks very annoying, it's really not as bad as one might think. The first thing I'm going to do is multiply all the significands together, and then I'm going to use our property of exponents to combine all those powers of 10. The significands multiply to the number negative 12, and the exponents simplify to negative 2. So I have negative 12 times 10 to the minus 2. But I need to move my decimal place 1 space to the left to make this in proper form. If I move the decimal one place to the left, that is going to decrease my power of 10 down to -1. So I'm going to have negative 1.2 times 10 to the -1. Really quickly, a rule about shifting decimals in scientific notations goes as follows. A left shift gives me a decrease in the exponent, and a right shift gives me an increase in the exponent. Alright, thank you for watching. Join us in our next video about radical notation.